In this example, we're going to be looking at smoking rates, which are per 100,000 people, and that might be a percent, versus lung cancer rates, which would be per 100,000 people, for the years 1999 through 2007. So as the rate of smoking goes down, it appears that the lung cancer rate per 100,000 people goes down as well. But let's see what the data actually looks like. I've already entered the data in my calculator. I'm going to go to second y equals and verify that my plot has been turned on. It has. It's on the correct plot. It's a scatter plot. And I entered my data in list 1 and list 2. What I'm going to do now is I'm going to hit zoom 9. And zoom 9 is going to give us a visual look at the data. Zoom 9 is the calculator statistics viewing window, and it offers the best viewing window that it can come up with for your data. If we look at the data, it appears to be linear in nature. It's not perfect, but if we were to draw a best fit line somewhere in here, it would be pretty darn close. So I'm going to describe the direction being positive. As x increases, then the value of y would increase. And likewise, as x decreases, so would the rate of lung cancer. The form is linear, and I'm going to say strong. We're going to calculate the linear regression equation. To do that, we're going to go to our statistics button, and then we're going to cursor right to calculate. We're going to go down to number 4, or you can just hit number 4 and hit enter. The calculator's default is set to list 1 and list 2. Let's just go ahead and enter that in though by hitting second and the number 1 key down here. You'll see list 1 pop in. You need to use a comma, which is just above your numbers. And then go second 2, and that'll be list 2. Now this is enough for the calculator to figure out the regression equation, but if you want your calculator to store it in y sub 1 and then you'll be able to see it on your graph, you can hit comma, hit the variables key, cursor 1 to the right to y variables, we want the function variables, and we want y sub 1. Your calculator now will find a best fit line for points with an x of list 1 and y of list 2 and store the equation in y sub 1. So here's the regression equation. We can see that a here is about 3.056. Let's go 3.06 around to the nearest hundredth. So we're going to write y with a little hat on the top. That means it's a prediction equation, which is what this is. And the slope, or a in this case, is 3.06. It's the same thing as m is in slope-intercept form. And then our b here is 22.04. So we'll do plus 22.04. You can also see here we get this nice r value of 0.94, and more on that later. But when an r value is close to 1 or negative 1, then it indicates that there is a strong correlation between the two variables. Let's check out this part D down here. So part D says, using your equation from part C, predict the lung cancer rate if the smoking rate is 17.3 per 100,000 people. And again, this is probably a percent. It's not believable that only 7.3 out of 100,000 people would smoke. So let's take a look at this. Y hat is equal to 3.06 times x, and x in this case will be 17.3. Remember, that's our x variable, is the smoking rate, and then we're just going to add 22.0. That'll give us a y value. Remember, the y value is the lung cancer rate, and that's what we're looking to find. We're looking to find the lung cancer rate here. So all I'm going to do is just type this in the calculator, 3.06 times 17.3 plus 22.04, and hit enter. And we get 74.978, or about 74.98. So y hat here will be 74.98. That makes sense in terms of the data as well. So let's take a look at that. The smoking rate is 17.3, which is somewhere lower here, and we can see these numbers are getting lower, so we're probably going to be somewhere in the 70s if we lower the smoking rate. And that is exactly what our prediction equation found out here, that the lung cancer rate would be 74.98.